hope everybody is doing well. So let's start off with today's session. So இன்னைக்கு வந்து நம்ம waves பார்க்க போறோம். So moving ahead. So we'll also finish the syllabus and accordingly we'll start off with the preparations. Okay, நான் ஷேர் பண்றேன். I'm sharing the audio also. So audio வந்து கரெக்ட்டா audible இருக்கான்னு ஒரு வாட்டி செக் பண்ணிக்கோங்க because I'm using a different system today. Okay, screen share ஆகுதுங்களா? You're able to see the screen?
Yes, sir.
Yes, sir.
Okay, great. சரி. So wavesல வந்து what do you mean by a wave? So நம்ம வந்து before we move on to the animations. So wavesனா என்னது? Any particular idea? யாருக்காச்சும் உங்க own wordsலயே சொல்லுங்க. Textbook definition வேண்டாம். So what do you understand by a wave? Yes?
Path that traveled by a particle.
Path traveled by a particle. Seri, so if an object is traveling in a straight line அப்படின்னா, so that is also a path traveled by a particle. So அதுவும் wave அப்படின்னு சொல்லுவோமா? That's also that come under a wave? இல்ல. Okay. So how can we put in? So wave அப்படிங்கிறது வந்து, so we can define that as with respect to the motion of the corresponding particles which are disturbed. Abdina, the disturbance which travels in a particular waveform. So நம்ம வந்து crest ன்னு சொல்லுவோம். We define it as a trough, or we also define as the propagation of disturbances in outer space. So அந்த மாதிரி we can try to put in the concept of wave. So duality, wave nature duality அப்படின்னு சொல்றோம். அப்போ வந்து நம்ம particles பத்தி பேசலாம். You talk about particles, you talk about the wavelets. So நம்ம அதெல்லாமே we are going to see all that in a brief. வந்து இந்த லெக்சர்ல வந்து we are going to cover. So we look at the waves. For example, சிம்பிளா நம்மளே wave create பண்ணணும் அப்படின்னா ஒண்ணுமே வேண்டாம். நம்ம வந்து ஒரு ட்ரேல தண்ணி எடுத்துக்கலாம். You can take a tray filled with water. நடுவுல வந்து ஜஸ்ட் ஒரு ஸ்டோனை வந்து நீங்க டிராப் பண்ணீங்கன்னா, have you experienced ripples in water? அது வந்து ripple அப்படின்னு சொல்லுவோம், ripple effect அப்படின்னு சொல்லுவோம். So you can see that waves are created. Yes. So ripple அப்படிங்கிறது கூட ஒரு type of wave தான். So அது வந்து wave motion அப்படின்னு சொல்லலாம். So அங்க வந்து என்ன travel ஆகுது? The disturbance, because you put stone, and the stone ஓட impact தான் is traveling around. So the disturbance is basically traveling. So we say that the disturbance being traveled, wave is a type of disturbance which travels through a medium. So wave வந்து ஒரு medium தேவைப்படாமலும் போகலாம். So it can require a medium or may not require a medium. So இப்போ light it also travels like a wave அப்படின்னு சொல்றோம். ஆனா லைட்டுக்கு medium தேவையில்லை. ஆனால் இப்போ சத்தம் டிராவல் பண்ணணும், சவுண்ட் டிராவல் பண்ணணும் அப்படின்னா அதுக்கு மீடியம் டெஃபினட்டா தேவை. வித்வுட் மீடியம் இட் cannot travel. ஸோ மீடியம் அப்படிங்கிறது நம்ம எதை சொல்றோம்? ஊடகம் அப்படின்னு சொல்லுவோம். ஸோ இட் நீட்ஸ் அ பர்டிகுலர் மீடியம் டு டிராவல். ஸோ certain waves require, certain waves don't require. சரிங்களா? ஸோ the waves which don't require we call them as the transverse waves. அது generally they are electromagnetic in nature அப்படின்னு சொல்லுவோம். The waves which require a medium, they are longitudinal. So they require a medium. இப்போ தண்ணியா இருக்கலாம், waves in water. It can be waves, it can be sound waves. So in the mari we can give many examples. சரிங்களா? So this is a broad idea of waves. So we will start off today's lecture. So first இந்த different types of waves நம்ம பார்த்துடலாம், and then we will move ahead. So first we will look at the transverse waves. சரிங்களா? So transverse wave நம்ம பார்க்கலாம்.
Transverse waves.
Yes, audible இருக்குங்களா?
A vibration or back and forth movement that travels through a medium. One familiar example is the ripples moving across the surface of a pond. If we drop a rock in a pond, we can watch the vibrations it creates in the form of ripples as they move across the water surface, beginning at the point where it struck the water. Based on how waves are transmitted, they can be one of two types, transverse or longitudinal. Let's look at a transverse wave in this session. A transverse wave is the movement or shaking of molecules in a vertical direction, meaning they are moving up and down a direction.
So transverse wave la வந்து how are the particles moving? They are moving in the vertical direction. அப்படினா இந்த vertical plane la தான் உங்களுக்கு அந்த motion இருக்கு, not in the horizontal plane. So that is one important property.
Perpendicular to the movement of the wave. As waves pass through a medium, it won't actually move along with the waves. If a stick is floating on the surface of our pond, as the ripples move across, the stick will only bob up and down while the ripples will flow past it. The stick won't move along with the wave. We can demonstrate a transverse wave by tying one end of a rope to a doorknob and shaking the other end up and down. In this case, the vibration of the rope will move forward as a transverse wave. Both radio and light waves move as transverse waves. Summary. A wave is a vibration or back and forth movement that travels through a medium. A transverse wave is the movement or shaking of molecules in a vertical direction that is perpendicular to the movement of the wave. Radio waves and light travel as transverse waves.
So these are the important concepts we learned in the small module la. So wave வந்து is a vibration that can move back and forth, இல்லைன்னா to and fro அப்படின்னு கூட சொல்லலாம், across a particular travels through a medium. So it can travel through a medium or even not without a medium. So transverse wave வந்து how it is moving, அந்த அதுல வந்து particles எப்படி மூவ் ஆகுதுன்னு பாத்தீங்கன்னா they are purely moving in the vertical plane. So எந்த ஒரு particle நம்ம எடுத்துக்கிட்டாலும் they are moving in the vertical plane. ஆனா wave வந்து was moving towards the right, but the particles are moving up and down. அதாவது இந்த vertical plane. So they are perpendicular to the direction of propagation of the wave அப்படின்னு சொல்றோம். So they are called as the transverse waves. So அதான் transverse waves ஓட nature. So this is how they are. So before that we'll go to the main module.
Transverse and longitudinal waves. Have you noticed the changes produced in still water when a pebble is dropped into it? A disturbance is created on the water surface which spreads outwards like waves. The disturbance produced due to the vibration of particles in the medium about their equilibrium positions is called a wave. The waves which require a medium for their propagation are called mechanical waves.
So inge வந்து they are vibrating the fork. So when the fork is vibrated, so you call it a tuning fork அப்படின்னு சொல்லுவோம். So அப்போ என்ன ஆகுது, the mechanical waves are created. So the air molecules are being disturbed due to the vibrations, and in the vibrations தான் travel ஆகுது. So you call them as mechanical waves, or even you can call them longitudinal. So inge the difference is you can see the particles or the vibrations are traveling parallel to the direction of propagation of the wave. That's the basic difference. So here the disturbance is traveling parallelly to the motion of the wave. அதாவது transversely இல்லனா mechanical wavesலயோ it is parallel, but it is in transverse waves. How is it going to be? It is going to be perpendicular. So in mechanical or longitudinal it is parallel, wherein in transverse waveforms it is going to be perpendicular. So that is the basic difference.
Okay. For example, the sound waves produced by a tuning fork are mechanical waves. The waves which do not require any medium for their propagation are called non-mechanical waves. For example, light waves are non-mechanical. Both kinds of waves carry energy from one place to another. Note that the particles of the medium through which the wave travels do not move along with the wave. A good example.
Yeah. So inge வந்து one more important difference is transverse wavelio illa non-mechanical wavelio. What is happening? The particles, they don't move. Particles are there where they are. They're just moving up and down. But What is transferred in the transverse waves? It is the energy that is being transferred. So energy transfer is taking place in transverse waves. For example, இப்போ நம்ம வீட்டில் வந்து for heating we are using a microwave oven. So microwave is a classic example of the transverse waves. So anga vandu the energy is basically traveling, but the particles which make up the transverse waves, they don't travel. So the energy is traveling, so that's why you are able to heat the food. So நம்ம எல்லாத்தையும் சாப்பாடை வந்து சூடு பண்ண முடியுது. That is because energy is only is basically moved from one point to another, or the energy transfer take place, but the particles of the wave, they don't move from one part to another. They just vibrate along the vertical plane. So that is what is observed in non-mechanical waves, such as transverse waves. Examples: X-rays, UV rays. So in the mari you can tell so all the electromagnetic spectrum la irukkudiya ella regions you can put it under the non-mechanical or transverse waves. So that is the difference. Okay.
Where one can see the disturbance traveling, but the medium particles not traveling along with the wave, is a leaf floating on still water ripples through it. Subsequent to a disturbance set in the water, the waves travel outwards. We see that the leaf stays where it was initially. The water particles simply move up and down about their medium positions. Based on the motion of the medium particles, mechanical waves are classified as longitudinal and transverse waves. Let's study these types of waves in detail.
So நம்ம இந்த ரெண்டு கேட்டகரியும் பார்க்க போறோம் in detail. Let's see. We have seen already in one of the module, but here we will see in detail. So the two different types of mechanical waves, what are they? One is longitudinal and the other is transverse. So எனக்கு examples கொடுக்குறீங்களா for longitudinal waves? Anybody? Your own examples?
X-rays.
X-rays are longitudinal, but X-rays don't require a medium to propagate, இல்லையா? So
Yes, sir.
ஆமா, X-rays வந்து longitudinal கீழ வராது. Sound waves சொல்லலாம். சரிங்களா? Sound waves in water you can say. Okay, where you have an up and down motion, especially when a stone or a log which is dropped in water. அதோட wave. அதுக்கப்புறம் what about the elastic motion of a spring நம்ம இழுத்து if you release, that is also an example of longitudinal waves. So அந்த மாதிரி you can say they all require a medium. Sound waves or longitudinal waves. So typically the waves which require a medium to propagate, they come under the category of longitudinal waves. So எதுக்கெல்லாம் medium தேவையா இருக்கோ for their propagation, so whichever waves require a medium for their propagation, you call them longitudinal, wherein the waves which don't require a medium for propagation, they are transverse. So that's the basic idea. So transverse la vandu all electromagnetic waves, you can call them transverse waves. Okay, so that is the difference. Sorry, we'll move on.
A wave which propagates parallel to the direction of vibration of the particles of the medium is called a longitudinal wave. Note here that the direction of propagation of the longitudinal wave is parallel to the direction in which the medium's particles are vibrating.
So both of them would vibrate along the same direction. So longitudinal waves the direction of propagation, அதாவது in which direction it is moving. Propagation or movement or traveling. So in which direction the wave is traveling, அதுவும் plus the vibrations of the particles which make up the wave, both of them appear to be parallel. So then you call such waves as longitudinal waves. So இதுதான் basic idea for longitudinal wave. ஓகேங்களா? Or it is also called as mechanical. இப்போ வந்து mechanical longitudinal ரெண்டுமே ஒண்ணுதான். So they are just calling it by a different name, that's it. So both mean the same. Okay, so we just now looked at an example. Sorry, let's move further.
Sound waves generated by a vibrating body such as a loudspeaker are longitudinal waves. A simple demonstration of a longitudinal wave can be seen using a long slinky held at one end by a rigid support. When the left end of the slinky is moved back and forth parallel to its length, notice the series of disturbances which travel through the slinky. The region of compressed portions in the wave is called compression. The region of relaxed portions of the slinky is called a rarefaction. A longitudinal wave is a series of alternate compressions and rarefactions travel.
So இது வந்து ஒரு demonstration. So demonstration of a longitudinal wave, which is a mechanical wave. So இதுல வந்து the direction of motion in which the rarefactions and compressions are traveling are the same direction as the direction of propagation of the wave. So ரெண்டுமே ஒரே direction நோக்கி தான் பயணிக்குது. So அதனால you call them as longitudinal waves. Plus they are parallel also. So that is why you call these as longitudinal waves. So what is compression? Compression ko rarefaction ko enna difference? Anybody? What do you mean by a compression and a rarefaction in a slinky or a spring? Yes, who can tell?
More magnitude of springs இருக்கிறது compression.
Okay.
லூஸா இருக்கிறது வந்து rarefaction.
Rarefactions, yes. So compressionsல பாத்தீங்கன்னா the number of turns per unit length would be greater. Would be அதாவது you have so many number of turns in a shorter area or in a shorter length. So you call them as the compression. So compressions the magnitude of the vibrations would be greater. Rarefactions they are dilated or they are expanded versions. So that is the difference. So these compressions and rarefactions are alternatingly moving. அதாவது இப்போ ஒரு compression இருந்துச்சுன்னா அதுக்கு பின்னாடி ஒரு rarefaction இருக்கும், அதுக்கப்புறம் அடுத்த compression. So அந்த மாதிரி consecutively they keep moving. So that is how you can see in longitudinal waves the compressions and rarefactions they keep traveling alternatively. And this is a classic example of the longitudinal waveform. Okay, so இது வந்து நம்ம ஒரு ஸ்ப்ரிங்கோ இல்ல ஒரு ஸ்லிங்கியோ ஒரு எண்ட்ல வந்து நம்ம ஃபிக்ஸ் பண்ணிட்டு the other end when you are going to move you can experience, you can demonstrate this. So it can be done using a slinky. The same way you can also demonstrate by using a spring. So normal spring also you can take, which is quite not that rigid. So adhe eduthu kuda you can demonstrate the same thing. Okay, so we'll move ahead. So that is about longitudinal waves. So we'll proceed further.
Traveling in a direction parallel to the direction of vibration of the particles.
Compression represents
a region of high density and high pressure in a given part of the medium through which a longitudinal wave initially passes. Rarefaction represents a region of low density and low pressure which succeeds the compression in the same part of the medium.
So with respect to density, அதுவும் அவங்க explain பண்ணிருக்காங்க. So with respect to density, what is the rarefaction? Rarefaction has a lower density. இப்போ நம்ம எல்லாருக்குமே தெரிஞ்ச ஒரு கான்செப்ட் density is number of, what is it? Mass per unit volume தான் நம்ம density அப்படின்னு சொல்றோம். So ஏன் rarefaction low density, compression எதுக்கு high density ன்னு சொல்றாங்க? That is because in rarefaction the number of turns per unit length is going to be less. ஆனா in compressions பாத்தீங்கன்னா number of turns per unit length is greater. அதனால தான் you call that as a higher density region. The compression becomes higher density region because the number of turns are greater per unit length. The same way in rarefactions the number of turns per unit length would be less, and hence they are, you say it is a low density region. Okay, I hope எல்லாருக்குமே புரியுதுன்னு நம்புறேன். That is why you call them as a higher and a lower density region with respect to a compression and a rarefaction. Okay, so we'll proceed further.
So, a longitudinal wave is a series of pressure and density variations produced in the medium while the wave propagates through it. The medium's particles oscillate about their mean positions as the wave passes by. They do not move along with the wave.
So they do not move along the wave, they just pass along their mean positions.
A wave which propagates in a direction perpendicular to the direction of vibration of the particles of the medium is called a transverse wave. Note here that the direction of propagation of the wave is perpendicular to the direction in which the medium's particles are vibrating. Plucking.
So transverse wave la vandu how the disturbance is moving, the disturbances move in the vertical plane, but wave is moving in the horizontal plane. Adanala da both of them appear to be perpendicular to each other. So that is why you say transverse waves la the direction of propagation of the wave and the direction of vibrations of the particles are perpendicular. Seringla? So that is an example. That is what is a transverse wave. So we'll look at the examples.
Plucking a guitar string generates a transverse wave. While the string is plucked perpendicular to its length, the wave produced in the string travels parallel to the string. A simple demonstration of a transverse wave can be seen in a long slinky held at one end by a rigid support. Now move the left end of the slinky.
இப்போ இது வந்து இங்க ஸ்லிங்கின்னு சொல்றாங்க. Actually this is not a slinky. இது வந்து this is a thread or a rope which is tied to one end. So ஒரு endல வந்து அவங்க tie பண்ணி அதை செக்யூர் பண்ணிருக்காங்க. So அது வந்து without moving. The other end is free to move. So அதை வந்து நம்ம up and down when you are going to move the thread, அப்போ என்ன ஆகுது? What is being produced? Transverse waves are produced. So this is a demonstration of transverse waves. So one end of the rope is being fixed. The other end is basically moved up and down. So you do an up and down motion, okay, or a back and forth motion. So appo enna agudhu? You can see that a transverse wave is generated. So appo adula if you take any point on the waveform, you can see those particles, they move in the vertical plane. But how is the wave moving? The wave is moving in the horizontal plane towards the rigid support. Therefore, you can say both of them appear perpendicular to each other, and hence you can come to a conclusion that it is a transverse waves. So upon appdi nama decide pannalam based on the direction of motion of the particles and the waveform, you can decide whether the wave is transverse or longitudinal. So that is the basic difference. Okay la?
Slinky up and down perpendicular to its length. And notice the series of disturbances which travel through the slinky. The crests of this wave are the elevated portions of the slinky, while the troughs are the depressed portions. A transverse.
So இப்போ வந்து two important points சொல்லியிருந்தாங்க. Crest அப்புறம் இன்னொன்று வந்து trough. So what do you understand by crest? Crest is nothing but the highest point that a particular waveform can achieve, the maximum height of the wave from the horizontal plane is called the crest. Trough அப்படிங்கிறது the maximum depth, the bottommost part of the waveform, you call that as the trough. So crest and trough. So transverse waves la da you can find these crests and troughs. Okay, in longitudinal waves you don't have crests and troughs. Adukku badala we have compressions and rarefactions. So that is the difference between transverse versus longitudinal. So this is an important concept that you should remember. What is the difference between crest and trough? So endha wave la crest and trough vandu undagudhu, plus what is rarefaction and compression, and which waveform can you see a rarefaction or a compression? So in transverse waves, you have series of crests and troughs, wherein in longitudinal waves, you have series of compressions and rarefactions. So compressions and rarefactions produce variation in pressure and density, wherein crests and troughs produce variation in the height of the waveform. So inga vandu the vertical displacement of the waveform is what is varying with the direction of propagation of the wave. சரிங்களா? ஸோ ஆம்ப்ளிடியூட்ல வந்து நம்ம வேரியேஷனை பார்க்கலாம் டிரான்ஸ்வர்ஸ் வேவ்ல. ஸோ ஆம்ப்ளிடியூட்னா என்னது? The amplitude is nothing but the maximum height reached by the waveform from the horizontal plane. You call that length as amplitude. சரிங்களா? ஸோ நம்ம அதெல்லாம் டீட்டெயிலாக பார்க்க போகிறோம். That's the basic things between transverse versus longitudinal. ஓகேங்களா? So we'll move on.
Transverse wave is a series of alternate crests and troughs. The medium particles which form the crests and troughs move perpendicular to the direction of motion of the wave. A crest is formed at the instant when the groups of the medium particles in the region are on the way up.
ஸோ இப்போ இந்த அனிமேஷன்ல இந்த சிமுலேஷன் வீடியோல வந்து உங்களால என்ன பார்க்க முடியுது? யூ கேன் see in this animation that அந்த ஒவ்வொரு ப்ளூ பாயிண்ட்டையும் நீங்க ஒன்று பார்த்தீங்கன்னா, ரொம்ப கூர்ந்து கவனிச்சீங்க அப்படின்னா, அதோட மோஷன் பார்த்தீங்கன்னா சும்மா அது மேலேயும் கீழேயும் தான் ஆசிலேட் ஆகிட்டு இருக்கு. They just moving up and down. That's all. But how is the wave moving? The wave is moving towards the right. Can you observe? So that is the observation. அதனால தான் you call these as transverse waves. Particles வெறுமனையே vertical planeல தான் மூவ் ஆகுது. பட் அந்த வேவ் நீங்க பாத்தீங்கன்னா the wave is moving towards the right, which is perpendicular. So that is why we call this as a transverse wave. அப்புறம் what is a crest? The maximum height reached by the waveform, and trough is the maximum depth reached by this waveform. Okay, so that's all the differences.
A trough is formed at the instant when the groups of particles in the region are on the way down. So, a transverse wave is a series of crests and troughs produced in the medium while the wave passes through it. The medium particles oscillate up and down about their new positions as the wave passes by. They do not move along with the wave.
So the particles, they don't move along with the wave. So அதனால தான் transverse waveல வந்து எனர்ஜி தான் ட்ரான்ஸ்ஃபர் ஆகுதே ஒழிய particle transfer does not take place. The particles, they don't get transferred. Only the energy is getting transferred. So that is why we say these type of waves are transverse in nature. Example, light. நம்ம லேசர் லைட் எடுத்துக்கோங்களேன். The laser has got various applications. So even nowadays, the laser is also used in the LASIK eye surgery. LASIK laser eye surgery in solvanga paranga. There it is used. So appo laser use panni they remove the corresponding layers in the eye. Cataract surgery kuda cataract removal பண்றதுக்கு யூஸ் பண்றாங்க. So appo அந்த laserல only the energy is being transferred. But the particles which make up the laser, they are where they are. They don't move. The particles remain where they are. They just oscillate about the mean position. Along the crest and the trough, they oscillate. Avladhan. But the energy basically is transferred. So energy abdingiradhu, you talk about the light energy. It can be in the form of heat and light. Idhe microwave la again heat energy da. You're trying to heat any object, food. Sarigla, X-rays. Again it is a type of energy. You're able to see the flaws in the human body. So on the mari you can look at different waves. Saringla, so this is all about the transverse waves. Edavadhu doubt irundhuchuna you can get it clarified. I hope it is clear, the transverse waves. Okay, shall we move further to the next part? Yes?
Yes, sir.
Okay.
Some of the major differences between longitudinal and transverse waves are: longitudinal waves travel in a direction parallel to the direction of vibration of the particles of the medium. Transverse waves travel in a direction perpendicular to the direction of vibration of the particles in the medium. Longitudinal waves consist of compressions and rarefactions. Transverse waves consist of crests and troughs. A set of one compression and one rarefaction constitutes one longitudinal wave. A set of one crest and one trough constitutes one transverse wave. Longitudinal waves can be formed in both solids and fluids. Transverse waves are possible only in solids. The similarities between longitudinal and transverse waves are that both exhibit the properties of interference, diffraction, refraction. Further, both types of waves carry energy while propagating from one point to another.
So this is the basic summary of transverse and longitudinals. நம்ம நிறைய points வந்து பார்த்திருந்தோம் in the differences. So we looked at how particles are vibrating, அதோட motion வந்து பார்த்தோம். Second, we looked at the difference between the nature of how the waves are propagating. இப்போ solids and liquids வந்து பெரும்பாலுமே you look that in longitudinal wavesல வந்து you can see, but transverse waves purely it is taking place in solids. So in the mari we looked at different examples here for transverse and longitudinal waves. The distinguishing factors or differences have been சொல்லலாம். சரி, let's move on.
Here's a quick summary.
This is the final summary of whatever we have learned. The basic summary. சரிங்களா? So now we'll move on to the next module. So I hope everybody is clear with what is transverse versus longitudinal, along with examples. அப்புறம் what is compression and rarefaction, அது ரொம்ப important. அதே மாதிரி transverse wavesல வந்து what is the crest, what is the trough, and crest and troughs எப்படி ஃபார்ம் ஆகுது transverse wavesல, அதே மாதிரி compression and rarefaction எப்படி ஃபார்ம் ஆகுது longitudinal wavesல. So அந்த ஒரு difference வந்து நம்ம பார்த்தோம். Second thing, compression and rarefaction வந்து it is formed in the longitudinal wave, and how it is creating it. How is the compression and rarefaction being created? Due to differences in pressure and density variations. Because of compression and rarefactions, there is a difference in pressure and density. இப்போ டென்சிட்டின்னு சொல்றாங்க, நம்ம அது புரிஞ்சுக்கிட்டோம். எதனால டென்சிட்டி வேரி ஆகுது அப்படின்றத பார்த்தோம். ஏன்னா the number of turns per unit length வந்து was greater in a compression than a rarefaction. That's why you say the regions of compression have a higher density இல்லையா than a rarefaction. That we saw. But pressure கூட இதோட relationship என்னவா இருக்கும்? We all know that pressure is defined as force per unit area. நீங்க எல்லாரும் படிச்சிருப்பீங்க. What is pressure? Pressure can be expressed as the amount of force exerted on an object per unit area. So அதுதான் நம்ம pressure ன்னு சொல்றோம். So force வந்து நம்ம எப்படி எழுதிக்கலாம்? Can you write force as mass into acceleration from Newton's second law of motion? Yes. So you can write F is equal to m into a. எழுதிக்கலாம். So it is force can be expressed as mass into acceleration upon area. A ன்னு எழுதிக்கலாம். So நான் வந்து இதை just show you how it is true. Just share a different screen. I'm explain பண்ணிட்டு then we'll come back. Yeah, I'm sharing a blackboard. Just tell me if you're able to see the blackboard. Okay, so blackboard visible இருக்குங்களா? I hope everybody is able to see. Sorry. So let me connect my stylus. Okay, so looking at this, so inga vandu we are just looking at how pressure is related, to the corresponding density. So first வந்து நம்ம ஒரு quick summary ஆவே பார்த்துடலாம் whatever we have learned. So we looked at what is longitudinal waves. So we looked at longitudinal waves. So in longitudinal waves, what are the basic properties? So first property of a longitudinal wave. So it is a wave which requires a medium for its propagation. Okay, so the waves that require a medium for their propagation. So you call them as a longitudinal wave, first and foremost point. ரெண்டாவது point என்ன பார்த்தோம் ஸ்லைட்ல, these longitudinal waves, the direction of motion, அதை பத்தி நம்ம பார்த்தோம், very important. So the direction of motion and the vibration, of particles are parallel or perpendicular. What did we say?
Parallel.
Yes, are parallel to each other. So that was the second point. Apro third point, we also looked at what is formed. They consist of alternate compressions and rarefactions. Yeah, so they consist of alternative compressions and rarefactions. So we looked at this. Finally, we looked at some examples also. What were the examples for longitudinal? Yeah, examples. So we had sound waves, and waves produced by the slinky, etc. So like this we looked at the examples. So adhe mari, how do you represent? So அந்த slinky use பண்ணி நம்ம represent பண்ணலாம். So slinky ல வந்து you had rarefactions and then you had compressions and then you had rarefactions இந்த மாதிரி and then you had compressions இல்லையா? So rarefactions and compressions. So இந்த மாதிரி நம்ம பார்த்திருந்தோம். So these regions, this is a rarefaction and this region is indicating a compression. This is a compression and this is a rarefaction. So what is this basically causing? So alternative compressions and rarefactions cause variation in density. So they are causing variation in density. Why density variation? Because density rho is given by the formula for density எல்லாருக்குமே தெரிஞ்சதுதான், mass per unit volume. Volume can be expressed as area into length அப்படின்னு எழுதிக்கலாமா in terms of volume. So mass divided by volume can be area into length. So we can write it like this. So the length, so if you look at the length of the compression or the length coming. So but rarefaction's length is greater. So that is the reason you say the compression has a greater density region. So the density part of compressions is greater than the density of rarefactions. So அப்படின்னு நம்ம எஸ்டாப்ளிஷ் பண்ணிக்கலாம். So that is one aspect. அதுக்கப்புறம் what is the relationship between the density and pressure? So அதுவும் பார்த்துடலாம். So relation between density and pressure. P அப்படிங்கிறது வந்து இங்க pressure. So what is the relationship? நம்ம அதுக்கு வந்து ப்ரெஷரோட ஃபார்முலால இருந்து ஸ்டார்ட் பண்ணலாம். ஸோ ப்ரெஷர் இஸ் ஈக்குவல் டு ஃபோர்ஸ் அப்ளைட் பர் யூனிட் ஏரியா. நான் அது ஏற்கனவே சொல்லியிருந்தேன் ஸ்லைடில். ஃபோர்ஸை வந்து நம்ம எப்படி எழுதிக்கலாம் இன் டர்ம்ஸ் ஆஃப் நியூட்டன்ஸ் லாஸ், மாஸ் இன்டு acceleration, right? We can write it like that, divided by area. Okay. இப்போ we bring the relationship. நம்ம எல்லாருக்குமே தெரிஞ்சது. So what I am doing here, I am multiplying with length on both the denominator and the numerator. So length ஓட multiply பண்ணேன்னா என்ன ஆகும்? மேல m into a இருக்கு, கீழே ஏரியா இருக்கு. So I am multiplying by length on both numerator and denominator. அப்போ you get n a into L, mass, acceleration into length, divided by area into length. What is area into length? Volume. Same way, mass divided by unit volume can be written as density. So rho into A into L. We can write it like that. So that's how pressure is related to density. In the Mari, you can bring in the relationships. So this is the variation of pressure with respect to density. This is a relationship. சரிங்களா? ஸோ அதனால தான் நம்ம ப்ரெஷரும் டென்சிட்டி ரெண்டுமே வேரி ஆகுது அப்படின்னு சொல்றோம். சேம் திங் இப்போ வந்து ஒரு டிரான்ஸ்வர்ஸ் வேவையும் பார்த்துடலாம். ஸோ இன் டிரான்ஸ்வர்ஸ் வேவ் வந்து வாட் இஸ் அ பேசிக் ஐடியா ஃபார் அ டிரான்ஸ்வர்ஸ் வேவ்? ஃபர்ஸ்ட் பாயிண்ட் என்னவா இருக்கும்? யூ டாக் அபவுட் த டைரக்ஷன்ஸ். ஸோ இன் டிரான்ஸ்வர்ஸ் வேவ் the waves they travel. How do the waves travel in transverse waveform?
Perpendicular to the direction of
Yes. Yes. So the waves okay, we will start like this. The wave particles travel perpendicular to the direction of propagation of the wave. So they are traveling perpendicular. So அது ஒரு point. அப்புறம் அதுக்கப்புறம் do they require a medium for their propagation? These waves do not require a medium to propagate. So sound Mario illa and the slinky Mario, they don't require any particular medium to propagate. So transverse waves, they don't require a medium to propagate. So that's one important property. They consist of, so அங்க வந்து rarefactions and compressions பார்த்தோம். அப்புறம் இங்க வந்து what did we look at in the slide?
thrust and trough.
Yes. So transverse waves consist of alternative crests and trough. Okay, alternative crest and trough regions. So that is the third point. Apro examples. Finally, examples. Can you give me examples of transverse waves?
Light waves.
Yeah. Examples are light light waves, அதுக்கப்புறம் microwave, microwaves, x-rays, இந்த மாதிரி you can give all the examples, etc., etc. So in general electromagnetic waves கூட சொல்லலாம். All electromagnetic waves are transverse in nature. Next, representation of a transverse wave. How can we represent? So how to represent a transverse wave? First, direction of propagation of the wave வந்து in one direction la இருந்துச்சு அப்படின்னா, so if it is going to be straight like this, then the particles which make up the wave, they just move in the vertical plane. So it forms a wave like this. In the மாதிரி it forms a waveform. So இதுல வந்து you call this as a crest, the maximum height which is reached, and this is a trough. So ஒரு series of crest and trough, இப்போ ஒரு இந்த வந்து points போடலாம். This is point A, say this is point B, and this is point C. So one complete wavelength அப்படின்னா one full crest plus one full trough. So அதுதான் one full wavelength அப்படின்னு சொல்லுவோம். So one full wavelength na this full region. சரிங்களா? So that complete region is one full wavelength. ஓகேங்களா? So one wavelength na lambda. Lambda is a symbol for wavelength. Okay va? So that is wavelength. So அந்த மாதிரி you have different representations for the corresponding wave. So here you have a crest, you had a trough, one complete wavelength. So all these things we can see. So amplitude. Amplitude is nothing but the height of the crest or depth of the trough. That's called as a wave amplitude. So அந்த மாதிரி நமக்கு we have important terms that you should be knowing. First is amplitude. Second வந்து wavelength. Wavelength ஓட symbol, amplitude symbol வந்து usually capital A use பண்ணுவோம். Wavelength வந்து lambda is the symbol. So wavelength is the series, okay, two consecutive crests or troughs. We call that as one wavelength. Okay. Crests or troughs. இல்லனா one full crest plus one full trough, that is also a wavelength. இத கூட நம்ம wavelength இந்த சொல்லுவோம். இந்த பாயிண்ட்ல இருந்து நான் இங்க மேல மார்க் பண்றேன். இங்க வந்து ரெண்டு crest இருக்கு இல்லையா? சோ இத கூட wavelength இந்த சொல்லுவோம். The distance between two consecutive crests or two consecutive troughs. So that is also one wavelength. What is the unit of wavelength? The unit of wavelength is the SI unit. The SI unit of wavelength is meters. Okay, for amplitude also the SI unit is meters only. So adukku meters da. Seringla? So this is the second one. Third one, what is time period? இப்போ time period of the waveform வந்து, so generally we represent using the letter capital T. So the time taken by the wave to complete one full waveform is called as one time period. Okay, the time taken by the wave to complete a full wavelength. To complete a full wavelength, you call that as the time period. So, இப்போ நம்ம இப்படி represent பண்ணோம் அப்படின்னா, when representing the wave again, so So I've just taken a wave here. So imagine you have it like this. So இப்படி இருக்குன்னு வச்சுக்கோங்க. So this is the origin of the wave. So இங்க வந்து 0. சரிங்களா? And so இங்க வந்து பாதி வேவ்ல தான் முடிஞ்சிருக்கு. ஒரு crest தான் கவர் பண்ணியிருக்கோம். இப்போ அடுத்த பாயிண்ட் பார்த்தீங்கன்னா இது வந்து origin 0, the time period is 0. இங்க வந்து the time period will be half. The moment one full trough is also covered, it is one full time period. அப்போ இந்த நடு பாயிண்ட் வந்து எப்படி எழுதிக்கலாம்? t by 2, half time period. This is full time period. அதுக்கப்புறம் what will be the next point? This point, what will be the time period? அதோட இன்னொரு half சேர்த்துக்கணும். t plus half, t plus t by 2 எவ்வளோ? How much do you get? You will get 3t by 2, isn't it? So in the mari it keeps going. Okay, so this is the time period. So one full time period is this from this point. For one wavelength என்ன time எடுத்துக்குதோ so அது வந்து one complete time period. This is one time period. Okay, so that's about the time period. அடுத்த term பாத்தீங்கன்னா frequency. Frequency இது வந்து we represent using a Greek symbol called as nu. இது வந்து v கிடையாது, பார்க்கறதுக்கு v மாதிரி தான் இருக்கும், but this is called as nu. nu ன்னு சொல்லி pronounce பண்ணுவோம், nu. It is a Greek alphabet. So frequency தான் என்னது? Who can tell me what is the
crossing a point.
yes. இப்போ இந்த term வந்து நம்ம we use it so many in different ways. Frequency of buses, frequency of trains, இல்லையா? So frequency of something அப்படின்னா how frequently it comes. So அதுதான் frequency, how regularly it repeats. So அதுதான் வந்து you call that as frequency. இப்போ இங்க கூட frequency-னா how frequently the wave is crossing a point in unit time. So you call that as frequency. So here we say frequency as the number of waves, crossing a point in unit time period. So the number of waves crossing a point in unit time period, you call it as frequency. So we can represent the frequency as reciprocal of time period. So 1 by t எழுதிக்கலாம். So this is the relationship between frequency and time period. Very important. This is the relationship between frequency and time period. So that's what I have repeated. So what is the unit of frequency? SI unit வந்து என்னவா இருக்கும்? Yes, hertz. But அதுக்கு முன்னாடி டைம் பாத்தீங்கன்னா இங்க டினாமினேட்டர்ல இருக்கு, மேல வந்து ஒன்றும் கிடையாது. So it is second inverse, or you also call it as hertz. The number of waves passing per unit time, per unit point, that is called as the frequency. Okay, so frequency can also be called as the number of cycles per second. Hz அப்படின்னு சொல்லுவோம் unit, which is hertz. So that is the unit. So frequency can also be expressed as the number of cycles or waveforms per second. This is also frequency. So this is all about the frequency. So we looked at frequency, we looked at time period, இதெல்லாமே பார்த்துட்டோம், and amplitude we saw. Okay, now we will relate. So relation between wavelength. So wavelength oda symbol வந்து lambda, and frequency symbol is nu, and time period. Okay, and time period and speed kuda we can take, and velocity. So for velocity we will use here a different letter. So we will take velocity as c, where c is the speed of light. ஓகேங்களா? You know that light is a transverse wave. So what is the speed of light in air or vacuum? Anybody?
10^8 meter per second.
So speed of light in air or vacuum, that value வந்து is, அது வந்து c ன்னு சொல்லுவோம், small c போட்டு ரெப்ரசன்ட் பண்ணுவோம். It is 3 into 10 power 8 meters per second. Correct. So that is the speed. So இப்போ இதை வந்து நம்ம எக்ஸ்பிரஸ் பண்றோம் அப்படின்னா, first வந்து we will use the relation from the relation. நம்ம relation வந்து ஏற்கனவே உங்களுக்கு தெரிஞ்சிருக்கும். Distance traveled. What is the formula for distance traveled in physics? Distance traveled d is equal to, yes, what is the formula for distance traveled by an object? Distance is nothing but speed into time, இல்லையா? Distance travel can be expressed as speed into time. Very important relationship. So I will write here. So distance traveled. So இதில இருந்து தான் நம்ம derive பண்றோம். Is equal to speed multiplied by time. So distance traveled அப்படிங்கிறது இங்க ஒரு wave formல வந்து the distance traveled is nothing but the wavelength. So wavelength is equal to speed of that wavelength. So speed of the wavelength வந்து, so obviously if you take a light wave, the speed of light in air or vacuum is going to be c. So c into t, where t is nothing but your, for a moment we are bringing the relationship for time period, yeah? So we will use capital T. So lambda is equal to c into capital T அப்படின்னு எழுதிக்கலாம். இப்போ what is the relation between time period and frequency? You know that t is equal to 1 by nu தானே, because nu was 1 by t. So t இடத்துல 1 by nu போட்டுக்கலாம். So அப்போ என்ன ஆகும்? So you will get lambda is equal to c by nu, isn't it? So lambda can be written as c by nu. So we can express like this. So that's how we can express. So this is the relationship between wavelength, speed of light in air or vacuum, and frequency nu. So this is the expression. Okay. So even nu can be written as c by lambda. So one more relation, just rearranging this. So this is the major relationship. So this is all the relationships that is important for us to keep in mind. This is the representation. ஒரு simple relationship, ஒரு question பார்க்கலாம். ஒரு simple question தரேன். So இதை ட்ரை பண்ணுங்க, எனக்கு ஆன்சர் என்னன்னு சொல்லுங்க. How far does the sound travel in air? How far does the sound travel in air when a tuning fork of frequency 256 hertz makes 64 vibrations. The velocity of sound in air So the velocity of sound in air வந்து is given as 320 meters per second அப்படின்னு எடுத்துக்க சொல்றாங்க. சரி, what is the answer? இதை எப்படி நம்ம சால்வ் பண்ணுவோம்? ட்ரை பண்ணுங்க. Yes, what is the relation? Yes, யாருக்காச்சும் ஆன்சர் கிடைச்சதுங்களா? என்ன கொடுத்திருக்காங்க? What is given in this question? Frequency கொடுத்திருக்காங்க, isn't it? So frequency symbol is nu. I'll put that itself. So nu is equal to 256 hertz. அதுக்கப்புறம் என்ன கொடுத்திருக்காங்க? The number of vibrations கொடுத்திருக்காங்க. N is given as 64 இல்லையா? 64 is given vibrations. 64 vibrations. அதே மாதிரி they have also given you the velocity of sound in air. So velocity கொடுத்திருக்காங்க, இல்லைனா ஸ்பீடுன்னு கூட எடுத்துக்கலாம். This is all given. நம்ம என்ன கண்டுபிடிக்கணும்? We should find out how far the sound travel in air. To find out the distance traveled by sound in air. அப்புறம் wavelength also you find. What formula we will use? So the formula that we use here is lambda order relationship, the wavelength relationship. So wavelength lambda is equal to frequency, அப்படியே போட்டுக்கலாம். C divided by nu. கரெக்ட். இங்க வந்து C வந்து ஸ்பீட் ஆஃப் லைட் கிடையாது, அவங்க கொடுத்திருக்கிற C தான். So நம்ம சேஞ்ச் பண்ணிக்கலாம். So we can write it as V divided by nu, where V is velocity. சரிங்களா? அப்படியே we can change. So find out the lambda. So 320 divided by nu was 256. Cancel பண்ணலாமா? If you cancel, what do you do? Ones are 1 point something வருது. I think 1.25. Okay, so lambda வந்து 1.25.
Yes, sir.
So lambda is the wavelength is 1.25. Yes. So wavelength வந்து 1.25 meters. சரிங்களா? Suppose you cannot do the cancellation directly, you can go for a simplified method. அது வந்து டீடைலா கூட you can do it. So உங்களுக்கு 5/4 வரும். நான் 5/4 தான் கன்வெர்ட் பண்ணிருக்கேன். சரி, so next இப்போ நமக்கு அந்த distance traveled வேணும். Distance traveled by the wave in 64 vibrations. So what is distance traveled? இது வந்து இந்த lambda நம்ம கண்டுபிடிச்சிருக்குது for one vibration. ஒரு வைப்ரேஷனுக்கு அது 1.25 meters பயணிக்குது. அப்போ distance traveled for 64 vibrations will be
64 into 1.
Yeah. So what is the distance if you calculate? So d is equal to n into lambda, which is n is 64 into 1.25. 64 into 125 by 100. So fourth table, if it is going, you can go ahead and you can cancel.
8.
So 8 times it's going. Okay, 80 times. So 80. So it is traveling 80 meters. சரிங்களா? 100 அப்புறம் 125 நீங்க கேன்சல் பண்ணலாமே. 25 டேபிள்ல it is going 4 times, right? And 25 5s are. அப்புறம் 8s are. So this one also you can do. Okay, 4 and 64. 16 times. So 16 5s are 80 அந்த மாதிரி வரும். சரிங்களா? So all that calculations you can do it. So distance traveled by this wave is 80 meters. அவ்வளவுதான். So this is how you're supposed to do it. சரிங்களா? Okay. So this is what we understand from this. So now we are moving on to the next concept. What is the velocity of the transverse waves? அடுத்த concept போலாம். The velocity of transverse waves in solids having modulus of rigidity. Modulus of rigidity வந்து eta அப்படின்னு சொல்லி represent பண்ணுவோம். And density நமக்கு தெரிஞ்ச ஒரு relationship, that is rho. So what is the velocity? What is the relationship? We'll see the relationship. So the relationship வந்து velocity v is equal to so velocity v is nothing but under root eta upon rho. So இந்த மாதிரி நம்ம எக்ஸ்பிரஸ் பண்ணலாம். Where eta is nothing but rigidity, modulus of rigidity, and rho is density. So this is one important relationship, very useful to solve many questions. So இது ஒன்று. இன்னொன்று கொடுக்குறேன். velocity of transverse waves திரும்பியுமே in a string கிடையாது, string, in a string of mass m and tension T. Tension அப்படிங்கிறது உங்களுக்கு தெரிஞ்சிருக்கும் நம்புறேன். The tension force, இல்லையா? Mass m and tension T. So அப்போ even then you have one relationship. So in that case the velocity will be v is equal to under root T by m. So this is the relationship. So these are the two units, relationships for velocities in transverse waves. So இதை யூஸ் பண்ணி we have the questions which are there. So first I'll give you one question. இதை try பண்ணுங்க. So first question, the speed of transverse waves produced in aluminium having rigidity modulus வந்து கொடுத்திருக்காங்க of aluminium, which is 2.1 into 10 power 10 Newton per meter square, and density கொடுத்திருக்காங்க 2.7 into 10 power 3 kilograms per meter cube. Is options are option A 2.59 into 10 power 3 meters per second. Option B, 2.69 into 10 power 3 meters per second. Option C, 2.79 into 10 power 3 meters per second. Option D, 2.89 into 10 power 3. So answer கண்டுபிடிங்க சொல்லுங்க. Standard question. Which is correct. So solve பண்ணிட்டு எனக்கு சொல்லுங்க. Yes. எவ்வளவு வருது? What is the formula? என்ன formula யூஸ் பண்ணுவோம்? V is equal to under root rigidity modulus divided by density. Then யூஸ் பண்ணுவோம். கரெக்டா யூஸ் பண்ண வேண்டியதுதான். So what is the formula coming? So simplify பண்ணணும் கரெக்டா. So இதை simplify பண்ணோம்னா rigidity modulus வந்து 2.1 into 10 power 10 இருந்துச்சு. அப்புறம் கீழே 2.7 into 10 power 3 இருந்தது. கரெக்டா? This is what was there. இப்போ 2.1 வந்து எப்படி எழுதிக்கலாம்?
21 into 10.
21 into 10 power 11. Minus 1 now. 21 into 10 power 10 or 9 or 11. அந்த 10 மேல கொண்டு போனோம்னா 10 power 9 ஆயிடும் இல்லையா? சேம் வே கீழே வந்து 27 into 10 power இங்க 3 இருந்தது. So this is 3. I'll put it as 3. So what do you get? So 27 into 10 power 2 தானே? Isn't it?
Yes, sir.
Yes. அப்புறம் 21 வந்து நம்ம எப்படி எக்ஸ்பிரஸ் பண்ணிக்கலாம் in terms of square numbers? Tell me. 21 can be written as 7 into 3. That is a possibility. Into 10 power and the 2 மேல கொண்டு வந்துருங்க. 9 minus 2 7. கரெக்ட்டா? 10 power 7 divided by கீழ 27 can be written as 9 into 3. 3 cancel பண்ணிரலாம். Okay, 3 can be cancelled. அப்புறம் you can bring it down. 10 power 7 வந்து you try to remove it out of the root. 9 I think can be removed. 9 வந்து 3 square வெளியில வந்துரும் இல்லையா? So 9 can come out as 1 by 3 under root 7 into
Power 7.
10 to the power of 7.
Yeah, 10 to the power of 7. So here what you can do is you can try to bring the 10 express 10 power 7 in terms of square values. அப்படியே எழுத முடியாது, but you can write it as 10 power 6 into 10 10 power 7. 10 power 6 வந்து 10 power 3 whole to the power 2 ன்னு எழுதிக்கலாம். கரெக்ட்டா? அதுக்கப்புறம் அந்த 10 cube வெளியில எடுத்துக்கலாம். Square representation. So 10 power 3 we can take it out divided by 3 under root உள்ள ஒரு 10 மிச்சம் இருக்கும். அந்த 10 and 7 you multiply, you will get 70. சரிங்களா? So root 70. So express in the minimum possible value. So 70 root value வந்து you should find out. So you do go for a prime factorization. So 270 வந்து how many times it's going? I hope it's 35. அதுக்கப்புறம் திரும்பி 2 ஆல you divide. So 35 by 2 எவ்வளோ? 17.5 இல்லையா?
Yes, sir.
Yeah. So திரும்பியுமே you keep repeating this. 17.5. So again you try to repeat it with, so it's ending with a decimal point 5. So try it out with 5.
8 point something, sir.
So 5 ஓட நம்ம பண்ணோம்னா திரும்பி 3.5 வருது. So
Sir, truly பண்ணலாமா?
2 you can make better to do in 2 itself. அப்போ என்ன வரும்? 8.75 வரும்.
8.75, sir.
So it keeps on going like that. So you should stop at a point where you're getting a square value. So திரும்பி if you're going to do this in 2, divide 4 point approximately 4.37 வருது. அந்த 4.37 வந்து நம்ம approximate பண்ணிக்கலாம். So that's how you would do it. So இங்க வந்து எத்தனை 2s இருக்கு? அது வந்து main. So you have 4 2s which can be written as, so 10 power 3 by 3 under root. So 70 can be written as 2 square into 2 square into 4.37. So I am removing it out. So அது 4 வெளியில வந்துரும். So 4 into 10 power 3 by 3 into root 4 ன்னு எடுத்துக்கிறேன். இது approximate 4 ன்னு எடுத்துக்கலாம். So in that case 2 will come out. So 4 2s are 8 by 3 into 10 power 3. So 8 by 3 value 2.66. Correct? So this is 2.66 into 10 power 3 meters per second. So that's the answer. Approximate answer is not exact. Approximate பண்ணிருக்கோம் நம்ம. ஓ அப்போ பாருங்க. So 2.66 na. Oh, it is very very close to which corresponding value that you have. So it is very close to option
B.
then. So option B.
Option
It is
B,
close to
sir.
option. So you go with approximation, you can use this. Option B it is. Sure. So that's how you solve this type of questions. Okay, அப்புறம் this type of questions you can have. So bulk modulus use பண்ணி we looked at one question. The same அதே மாதிரி you can also have உங்களுக்கு dimensions கொடுத்து கூட question கேட்கலாம் by giving you the different dimensions. So that is also there. Possibility is there. One question I will give you. இது வந்து நீங்க you can try it later. I'm just giving you, or you can try it now also. Next question. A copper wire is held at two ends by a rigid support at 30 degrees Celsius at 30 degrees Celsius. The wire has negligible tension. Find the speed of transverse waves. இல்லைனா இப்படி போட்டுக்கலாம். The speed of transverse waves in the wire at 10 degrees Celsius is? Options. Option A, 2 meters per second. B, 72 meters per second. C, 92 meters per second. And D, 102 meters per second. So these are the options. So this also you can try. We have 5 minutes, 5 to 8 minutes more. So இதில் என்னென்ன கொடுத்துருக்குறாங்க, ஃபர்ஸ்ட் ட்ரை டு அண்டர்ஸ்டாண்ட் வாட் இஸ் கிவன் இன் த கொஸ்டின். என்ன கொடுத்துருக்காங்க, என்ன அவங்க கேட்குறாங்க, அதை பேஸ் பண்ணி நம்ம டிசைட் பண்ணிக்கலாம் எப்படி சால்வ் பண்ணுறது அப்படி. ஓகேங்களா? ஸோ சர்டன் வேல்யூஸ் ஐ வில் கிவ் ஹியர். இதில் வந்து கொஞ்சம் they give us the values as coefficient of linear expansion கொடுத்துருக்காங்க as 1.7 into 10 power minus 5 degrees per Celsius. அது கொடுத்துருக்காங்க. அதுக்கப்புறம் யங்ஸ் மாடுலஸ் கொடுத்துருக்காங்க, just 1.4 into 10 power 11 newtons per meter square. அப்புறம் டென்சிட்டி கொடுத்துருக்காங்க 9 into 10 power 3. These are all given for copper. So இதெல்லாம் கொடுத்துருக்காங்க கொஸ்டின்ல. This is a given data. At 30, they are saying the tension is kind of negligible. So we have to find out what is the corresponding tension that is produced in the wire when there is a change in temperature. So அந்த மாதிரி ஒரு அப்ரோச் தான் இந்த கொஸ்டினுக்கு வந்து தேவை. சரிங்களா? ஸோ இதை நீங்கள் ட்ரை பண்ணுங்க.
மேபி அது ஹோம்வொர்க்காக கூட அவங்க எடுத்துக்கலாம்னு நினைக்கிறேன்.
Yes, you take it as homework. Let us not rush in. So either try பண்ணுங்க. We'll discuss in the next class.
Okay. Manish, I have one question. இப்போ வந்து நீட் அல்லது ஜேஇல நார்மலி தே சே 11th ஸ்டாண்டர்ட் சிலபஸ்லேருந்து கொஞ்சம் அதிகமான கேள்விகளும் 12th கொஞ்சம் குறைவாக கேள்வி வரும்னு சொல்கிறாங்க. அது உண்மைதானா? 60-40ங்கிற மாதிரி ஒரு ஃபீலிங் இருக்குது. இஸ் இட் கரெக்ட் ஆர்?
யூசுவலி சார் அது வந்து டிபெண்ட்ஸ், பட் 11th இருந்து கேக்குறாங்க. எஸ்,
ஆமா. The other question,
கொஞ்சம் percentage will be little on the higher end. ஆமா, that is true.
ரெண்டாவது
ஏன்னா because of the boards க்கு வந்து they usually the kids give their board exams before giving the JEE or NEET.
Correct.
So they are very well versed with 12th syllabus.
Okay.
So அதனால they try to ask from the 11th also.
Okay. செகண்ட் வந்து the question the ப்ராப்ளம்ஸ் எல்லாம் அதிகமாக 11th portion வரும், 12th வந்து ப்ராப்ளம்ஸ் குறைவாக வரும்ன்றாங்க. சிலபஸே அப்படி தான் இருக்குங்கிறாங்க.
Numerical not be true. Numericals வந்து sir electricity வந்து has a lot more questions which is there. அது வந்து நம்ம 12th பாத்தீங்கன்னா has a greater weightage.
Okay.
Electrostatics, அதுக்கப்புறம் electricity,
மெக்கானிக்ஸ் வந்து 11th இருக்குது.
ஆமா, மெக்கானிக்ஸ் வந்து இருக்கு. மெக்கானிக்ஸ்ல வந்து ஒத்துக்கிறேன், there is a lot of questions which will come. அதே மாதிரி அதுக்கு proportionate they ask from 12th also, no, that is also there.
Okay. சரி, ஓகே. இல்லை, இந்த ரெண்டு இது எனக்கு ஒரு யாரோ கேள்வி கேட்டாங்க. எனிவே, தேங்க்யூ மனிஷ். வி வில் மீட் அகெயின் இன் த நெக்ஸ்ட் சண்டே.